Engineering. I am Dr. Kavita, Assistant Professor of Computer Science, Mother Teresa Women's University, Kodaikanal. In this video, we are going to discuss the following topics: introduction, key techniques of software engineering, attributes of software engineering, importance of software engineering, some size factors. Let's see the topics one by one. First, introduction. It is a systematic approach to design, develop, test and maintain the software. It includes a variety of techniques, tools and methodologies for improving the software development process. The main goal is to create a high quality, reliable and maintainable software. Okay. The key process, these are all the key processes involved in software engineering: requirement analysis, design, development, testing and maintenance. Let's see the concise part of each key process. The first one is requirement analysis. Needs and expectations of the software are identified and documented in this stage. Here the information that the expectations can be collected from the stakeholders like customers, users or from some organizations. Then next key process is design. So after gathering collecting the requirements, the design phase will be involved. In this phase, it involves planning the architecture and layout of the software. Here it includes two types of design: high level and low level design. See, high level design is used to define the overall system architecture, which identify the main components and their interactions. Then that low level focuses the internal workings of each component that represents the data structures and algorithms. Then next phase is development. Here it involves writing the actual code for the software based on the design pattern. Here the programmers, they can use various coding languages and tools to build the features and functionalities defined in the requirements. The main focus is, in this part, we have to write an efficient, error-free, scalable code. Next phase is testing. Testing checks ensure that a software functions perfectly, which means it satisfies all the user requirements. Here it involves unit testing, integration testing and systems testing to ensure the software functionalities. The first one, unit testing, is used to test the individual components of the software product. Then second one is integration testing. Integration testing ensures that the different components work together. Then third one is system testing. It validates the entire system of the software product. The main aim is to find and fix the errors, ensure performance standards and verify that the software behaves as expected. Then next phase is maintenance. So after deployment, the software needs ongoing support to fix the errors, enhancing the features and adapt to change the user needs at any time. So it is a critical phase as software needs to evolve to stay relevant and functional over time. So these are all the key processes. These key processes ensure that The software is developed systematically, it satisfies user requirements and remains relevant throughout its software development life cycle. The next, the term software engineering. The software engineering that can be composed of using two words, software and engineering. Software, it is a program or a set of programs which can be created by the developers by using various programming languages. Engineering is a discipline or a application of scientific knowledge to invent, design, build, maintain and improve the frameworks and processes. So, we can define the software engineering is a branch of engineering focused on the development of a software product using well defined scientific principles, methods and procedures. The major outcome of software engineering is to produce efficient and reliable software that meets user needs. So, software engineering is a structured approach that organizes past experiences that can be organized into methodologies and guidelines. While we talk about the small program that consists of only a minimal code, so the principles of software engineering is not necessary in this part. While we consider a complex program means it consists of a large number of codings. So, the principles of software engineering is very essential to develop large and high quality software. Generally, large software programs required in industries which are more complex and challenging as their size increases. So, the challenge, the software engineering addresses this complexity by using two key techniques, abstraction and decomposition. Abstraction. Abstraction simplifies the complex problems by focusing the relevant part and ignoring the irrelevant portions. Here it's once the relevant portion can be solved means the ignored part can be taken into consideration for next level of abstraction. So, here it helps to reduce the complexity and makes the problem easier to manage. Then the next technique, decomposition, it breaks the large problem into smaller independent parts. Each individual part, each part is solved individually, which minimizes the interaction between the components. Here it ensures efficient problem solving and a combination of solutions. These techniques allow software engineers to manage the increasing complexity of large software systems, ensure more organized and efficient development process. The next, let us see the other key techniques involved in software engineering. First one is encapsulation. It groups data and functions into a single unit. Here it protects the internal part from other parts of the software, that is encapsulation. Then second key technique is reusability. The design components, the predefined design components can be reused in different applications. It saves development time and resources. Then third technique is maintenance. The regular updation and improve software, it fix the errors, add features and enhance security. Then next key technique is testing. As I said earlier, testing that ensures that software functions perfectly, which means free of errors, by using 3 types of testing, as I explained detail in earlier: unit testing, integration testing, and system testing. Then next technique is design patterns. Here we use established templates to solve common design problems, which makes the development process very, very easier. Then next topic is attributes of software engineering. Here there are basically there are 4 attributes: efficiency, reliability, reusability, and maintainability. First one, efficient, means it measures how the resources can be consumed for the particular product. Then reliability means it assures that software deliver the same result while we use it for in similar working environment. Then third one is reusability. It makes sure that the predefined module can be used in multiple applications. Then finally, maintainability. It is the ability of the software to be modified or repaired or enhanced easily while changing the requirements. The next, classification of software. Software can be classified based on the priorities, terminologies. The first terminology is purpose. The purpose can be measured by using these 2 things: scheme software and application software. That scheme software can be developed to monitor and control the operating system and device drivers. Application software can be used to develop for performing some task. The example are word processors and games. Then next terminology is platform. The platform that may be either Navy software or cross-platform software. Cross-platform software is designed to run the software product on multiple operating systems. The Navy software is designed for a particular operating system. This is the difference between these 2. Then next terminology is deployment. The deployment, that information that can be stored either in the installed software or in the cloud-based software. Installed software that held in the user's device. Cloud-based software means it hosted on remote servers that can be accessed through the internet. Then next one is license. It may be from either be proprietary software or open source software. Open source means it is free, it is available for free with source code. A proprietary, it is owned by the single entity by using a subscription. Then next terminology is development model. We can develop either a traditional software or agile software. The traditional software can be designed using waterfall model. Then the agile can be developed using iterative and adaptive approach. Then next terminology is size. The size may be either designed for a single user with a minimum number of codes. We can also call it as a small scale software, or can be developed for enterprise software designed for large organizations. Then next terminology is user interfaces. See here, the user interfaces may be either we can design it for graphical user interface or a command line interface. Graphical user interface software that provides you visual interfaces. It allows the users to interact with graphical elements. Command line interface software, it allows the users to interact with operating system and software by using text commands. The next, types of software. Basically, there are two types: system software and application software. System software is used to manage computer resources and support the execution of application programs. The example of system software is operating system, compilers, editors, and drivers. Application software is designed to perform some tasks to fulfill the user's requirement by interacting the users directly. The types of application software are generic or customized. Generic software. Generic software means it is a software which is open to all. It behaves the same for all the users, but the functionalities available in the generic software is very, very limited, and we cannot customize that part. The users, that they cannot change the requirements. Then customized software means it is a product designed for a particular client, which is not available for all. That is customized software. Then next topic is importance of software engineering. First one is reduces complexity. So by using that abstraction, key terminologies abstraction and decomposition, we can simplify the complex problems by breaking the big problems into smaller manageable issues. Then next, minimizes software cost. Obviously, once we simplify that complexity means automatically it reduces the cost. Software engineering principles helps to reduce the unnecessary work and optimizes the resources and makes the software development more cost effective. Then next, decreases development time. See, the software engineering streamlined the process stage by stage to ensure that the project follow a structured approach. Automatically, it reduces the time spent on trial and error method. Then next importance is handles large projects. It ensures that complex projects are organized and manageable. It enables the teams to meet the deadlines efficiently. Then ensures reliable software. The delivered software function properly with no errors. That can be, if there is any error means that can be quickly resolved, which provides long-term reliability. Then next one is increases effectiveness. It helps align projects with the software engineering principles and standards. It enhances the overall performance and effectiveness of the software. Then next, parameters defining the software project. Cost, schedule, and quality. These three key parameters are available in for defining the software project, which ensures the software product is developed efficiently with high standard and cost effective. Then let us see what is the difference between program and software product. Program is a set of instructions that can be used to perform a task to the computer. On the other side, software product is a set of programs or applications which makes available for commercial purpose. Along with that coding applications, we have to keep the documentation, appropriate documentation and licensing terms. So, the software products include program, documentation and license. Here in the program side, program is one of the stages involved in the development, software development life cycle. But in the software product side, it follows the entire life cycle, which involves feasibility study of the project, requirement gathering, development of a prototype, system design, coding and testing. So, software product that can be delivered to the customer with the proper documentation. It describes how to install and use the proposed system. These software products are produced with the help of software process. The types of a software product are generic and customized. Generic product means it is a standalone systems developed by a production unit that can be sold on the open market. To any customer can buy, can use this product, that is a generic product. Then next one is customized product. This can be designed for a particular customer. Some contractor develops this type of software for a particular customer. Then next, some definitions, we often use it in the software engineering. First one is programmer, a person who involves in writing and modifies the code, or programmers, okay, by using programming languages or programmers. Software engineers, beyond that program coding, so he must handle tasks like analysis, design, testing, documentation, maintenance and project management. Then next, computer software. We may also call it as program or source code or product. It includes both the source code as well as the documents related to the software product. Then next one is documentation. Documentation describes external and internal structure of the software product. It involves internal documentation and external documentation. Internal documentation describes the code itself. That external documentation describes the code for easier understanding and use. Then next, customer, maybe an individual or organization requesting the software creation or a modification of software. Then software quality, that quality that can be measured by using the following parameters or attributes: usefulness, clarity, reliability, efficiency and cost effectiveness. First, usefulness. The important quality is usefulness. It ensures that software meets or satisfies the user requirements. Then software reliability, the ability to perform the software functions perfectly on time, that is software reliability. Then efficiency, it is efficient only to the extent necessary for the application, that is efficiency. Then cost effectiveness, it must be considered in terms of development, maintenance and usage while maintaining high quality, high reliability and efficiency. There are so many career opportunities are available in software engineering. I have listed a very few here. after pursuing that software engineering, you may be a software engineer or a software development engineer or a web developer, quality assurance engineer, web designer, software test engineer, cloud engineer, security engineer, or a front end or a back end software engineer. Some size factors. Here we will see the level of efforts can be distributed to software development and maintenance. In this topic, we will see the total effort devoted to the software and distribution of effort. The next topic is project size categories and how programmers can spend their time during software development. First, let us see the total effort distributed to software utilized for software development. In earlier days, like in 1980, the total amount spent in all aspects of computing in US is 5% they have spent for all aspects of computing in US. Now, later it was estimated 8% in 1985, 12.5% in 1990. Now it is in 2024, it is 9.3%. The expenditure includes software, IT services, cloud computing, etc. Here the current demand of software technologists exceeds that available supply. The demand will exceed supply by 7.5 to 20 lakhs people in 1990. Now it is gradually increased. So the major goal of software engineering is to provide tools and techniques to increase the productivity of the available software engineers. Next, career opportunities in software engineering. There are n number of career opportunities available in software engineering. I have listed a highlighted opportunities here. Software engineer, software development engineer, web developer, quality assurance engineer, web designer, software test engineer, cloud engineer, security engineer, or a front end or back end software engineers. So in this video, we have discussed the introduction of software engineering and how to define that the term software engineering, importance, attributes and career opportunities in software engineering.